Welcome back to Terminal Bash. This is the Rust programming language book. We're on chapter 7 here. This is managing growing projects with packages, crates, and modules. In the last episode, we covered enums and pattern matching. And the one prior to that, we talked about structs and structurally related data. All right. So, as you write large programs, organizing your code will be important. Sure is. So, grouping related functionality and separating code with distinct features, you'll clarify where to find code that implements a particular feature and where to change how a feature works. Okay. The programs we've written so far have been in one module in one file. As a project grows, you can organize your code by splitting it into multiple modules and then multiple files. A package can contain multiple binary crates and optionally one library crate. Okay. As a project grows, you can extract parts into separate crates that become external dependencies. This chapter covers those techniques. For very large projects, a set of interrelated packages that evolve together. Cargo provides workspaces, which we'll cover in the Cargo Workspaces section in Chapter 14. Okay. Encapsulating implementation details lets us reuse code at a higher level. Once you've implemented an operation, other code can call that code via code's public interface without knowing how the implementation works. The way you write code defines which parts are public for other code to use and which parts are private. This is another way to limit the amount of detail you have to keep in your head. Okay. So, related concept is scope. The nested context in which code is written has a set of names that are defined as in scope. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name at a particular spot refers to a variable, function, struct, enum, module, constant, or other item, and what that item means. You can create scope and change which names are in or out of scope. You can't have two items with the same name in the same scope. Tools are available to resolve name conflicts. Cool. So this is nothing new. If you've programmed any other language, that's pretty standard. Alright, so packages are a cargo feature that lets you build, test, and share crates. Crates are a tree of modules that produce a library or executable. Modules and use let you control organization, scope, and privacy of paths. Paths, a way of naming an item, such as a struct, function, or module. Okay, so that's our terminology of the chapter. In the chapter, we'll cover all the features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of a module system and be able to work with scopes like a pro. Looking forward to it. All right. So, let's talk about packages and crates. The first part of the module system we'll cover are packages and crates. Crate is a binary or library. Crate root is a source file that Rust compiler starts from and makes up the root module of your crate. A package is one or more crates that provide a set of functionality. Package contains a cargo tuple. Several rules determine what a package can contain. A package must contain 0 or 1 library crates, no more. It contains as many binary crates as you'd like, but it must contain at least one crate, either library or binary. Okay, let's walk through what happens when we create a package. So first, we'll enter the command cargo new. So nothing too new here. All right. CD into Rustbook. We're going to cargo new, and we're going to call it chapter 7. We'll just say packages and crates. So we created a new binary application, and if we look, we can see that it's created chapter 7 for us here. So we'll CD into there. CD into there. And we can see that we've got the tuple and source created for us. When we enter the command, gave us the tuple and main RS. Likewise, cargo knows that if a package directory contains source librs, the package contains a library crate with the same name as the package, and source librs is its crate root. Cargo passes that crate root files, the crate root files, to rustc to build the library or binary. All right, here we have a package that only contains source main.rs, meaning it only contains a binary crate named my project, in the case chapter 7. If a package contains main and source librs, it has 2 crates, a library, and a binary, both with the same name as the package. A package can have multiple binary crates by placing files in the source bin directory. Each file will be a separate binary crate. A cargo or a crate will group related functionality together in a scope so the functionality is easy to share between multiple projects. For example, the rand crate we used in chapter 2 provides functionality that generates random numbers. We can use that functionality in our own projects by bringing in the rand crate into our project scope. All the functionality provided by the rand crate is accessible through the crate's name rand. Keeping a crate's functionality in its own scope clarifies whether particular functionality is defined in our crate or the rand crate and prevents potential conflicts. Cool. Let's move on and talk about the module system. All right. So in this section, we'll talk about modules and other parts of the module system, namely paths, which I'm not terribly familiar with, but it's probably just terminology differences. So it allows you to name items, the use keyword that brings the path into scope. Yeah, it's just the namespace. And the pub keywords that make items public. We'll also discuss as for aliasing, external packages, and the Glob Operator. For now, modules. Let us organize code within a crate into groups for readability and easy reuse. Modules also control privacy of items, which is whether an item can be used outside code, public, scope, or is an internal implementation detail and not available outside use. And that's private. As an example, let's write a library crate that provides the functionality of a restaurant. We'll define the signatures of functions but leave their bodies empty to concentrate on the organization of the code rather than actually implementing a restaurant in code. In the restaurant industry, some parts of the restaurant are referred to as front of the house, others as back of the house. Front of house is where customers are. This is where host seats, customers, servers take order and payment, and bartenders make drinks. Back of the house is where chefs and cooks work in the kitchen, dishwashers clean up, and managers do administrative work. To structure our crate in the same way that real restaurants work, we can organize functions into nested modules. Create a new library named restaurant by running crate new lib restaurant. then put the code in 7.1 into librs inside of the source directory. Okay, so this will be cargo new from within our existing repo that we've already gone into. So we'll go ahead and do that. Cargo new -- lib, and then we'll just copy and paste that because I don't want to misspell it. Okay. And if we lost source, okay, so it actually ended up creating a whole new project. So what we're going to do, we're going to move restaurant up, and then we'll go up that directory into restaurant. So now you can see here I was in get restbook chapter 7. Now I've just moved it up into being a sibling of chapter 7. So now we will vim our librs, and we want 2 modules nested inside of 1 module. So I'm going to type this out. It's already got stuff in there. It just says put it into it, so I'm not sure if it means. It's kind of weird. I wonder why it did that. I'm gonna get rid of that. Who knows? All right, so mod front of house, and then that's gonna open up a block scope. Mod hosting, and then mod serving. Okay. So for the module for hosting, we're going to have 2 functions: add to waitlist, seated table. So add to waitlist and a function for seat at table. And then serving is probably going to be like take order, serve order, take payment. Okay. And yeah, I guess I can put these on one line. No harm in that. Function take order. Function serve order. Function take payment. Okay. That all makes sense. By using modules, we can group related definitions together by name and why they're related. So this is what it ends up looking like. Tree shows how some of the modules nest inside the other. The module tree might remind you of a file system's directory tree on your computer. This is a very apt comparison. Just like directories in a file system, you can use modules to organize your code. Cool. And so I don't know if there's a way to see the module tree. But all right. So that makes plenty of sense. Paths for referring to an item in the module tree. Path can take 2 forms. An absolute path starts from the crate root by using a crate name or a literal crate. Relative path starts from the current module and uses self, super, or an identifier in the current module. Both absolute and relative paths are followed by 1 or more identifiers separated by double colons. So back to 7.1, how do we call add to waitlist function? So we're going to create a new public function outside of the scope of front of house. Okay, so this is where we get our public scope, and it's going to call eat at restaurant. And restaurant you spell that? Maybe. Okay. So then from our crate, which is the crate root, front of house, hosting, add to waitlist. Okay, so crate, front of house, hosting, and then add to waitlist. And then relative path, because we're already in front of house, we could just specify that. I would probably do that myself. Just leave it like that. First time we called add to waitlist, we used absolute path. The add to waitlist function defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. After crate, we include each of the successive modules until we make our way to add to waitlist, which is a function. You can imagine a file system with the same structure, and we'd specify the path to run add to waitlist using crate name to start from the crate root is like using / in a file system. Okay, second time we can do it in a relative manner. Starting with names means the path is relative. Okay, so basically, if it's anything but the crate keyword, it's relative. Choosing whether to use relative or absolute is a decision you'll make based on your project. Probably set some standards beforehand. This decision should depend on whether you're more likely to move the item definition code separately from or together with the code that uses the item. For example, if we're moving front of house module and the eat at restaurant function into a module named customer experience, we need to update the absolute path to add to waitlist, but the relative path would still be valid. Pardon me. However, if we moved eat at restaurant function separately into a module named dining, the absolute path to the add to waitlist call would stay the same, but the relative path would need to be updated, and so on. Okay, let's try to compile and see why it won't compile yet. Okay, so cargo build. Rest book, restaurant, cargo build. And hosting. Module hosting is private. So in which case, the error message says module hosting is private. In other words, we have the correct paths for a hosting module, but Rust won't let us use them because we don't have access to private sections. Modules aren't useful only for organizing code. They also define Rust's privacy boundary, the line that encapsulates the implementation details external code isn't allowed to know about, call, or rely on. Okay. The way privacy works in Rust is that all items, functions, methods, structs, enums, modules, and constants are private by default. Items in a parent module can't use the private items inside the child modules. But the child modules can use the items in their ancestor modules. The reason is that child modules wrap and hide their implementation details, but the child modules can see the context in which they're defined. To continue with the restaurant metaphor, think of privacy roles as being a little, or like the back of the office of a restaurant. What goes on in there is private to the restaurant customers, but office managers can see and do everything in the restaurant in which they operate. So you got to prefix it with pub. So we've got the front of the house, and if you want to know more, you must make it public. So now it's mad. Let's find out why. And then we must make this public. And then these functions are never used, and that's fine. Right, so now we just have warnings about functions never being used. But it does finish. And then if we were to cargo run, a bin target must be available. Yeah, we don't have that. Okay, so unfortunately, still results in an error. So what happened, adding pub keyword in front of mod hosting makes the module public. With this change, if we can access front of house, we can access hosting, but the contents of hosting are still private, so we need a pub keyword on the function. Ta-da. Now, you'll notice that they got rid of the rest of the functions there. Adding the pub keyword to mod hosting and function add to web or waitlist lets us call the function from eat at restaurant. Now with the code, now the code will compile, look at the absolute and relative path, double check why adding the pub keyword lets us use these paths. Okay. It's all straightforward to me. Starting relative paths with super. So that's going to call up to the parent. We can also construct relative paths that begin with the parent module by using super at the start of the path. EverX, welcome, good morning, good to see you again. This is like starting a file system path with ... Sure. So you can say super, which goes up to back of house, serve order, which would call serve order if there was one. Oh, I see. So it actually goes above. So, because this is not a module. Sorry. This is just a function. So super will go one scope above the module, which happens to be the crate itself. The fix incorrect order function is in the back of house module, so we can use super to go to the parent module back of house, which in this crate, your case is crate. Yeah, there you go. From there, we look at serve order, find it, success. Moving on. Making structs in a enum pub. It's the same concept. It's just, so you've got your pub struct breakfast, and then your implementation of breakfast, which is basically functions that are a descriptor or a receiver of the breakfast struct. So we can say public function summer gets public just as breakfast is. So then when we're out here in this scope, we can say back of house, right? Back of house, breakfast. Let's try that again. We can say back of house refers to back of house. Breakfast refers to breakfast, which is allowed because it's public. And back of house is allowed because we're in the crate. Summer, and summer is allowed because of pub. Right? So if these pub keywords weren't here, it wouldn't work. And then we pass in our toast as a slice of a string. Okay, so meal toast, string from wheat. This is not a slice at that point. That is just a string. This from keyword, or this from function, allocates memory from the OS, and then the implicit return will free that memory. Okay, so because the toast field in the back of house breakfast struct is public in eaten restaurant, yeah, so basically all of what I summarized. So in contrast, if we make an enum public, all of its variants are then public. Okay, we only need the pub before the enum keyword. Makes sense because, well, but enums can have, okay, this we need to test, right? So we'll cd up and we'll make a directory. Yeah, we will create new cargo new, and it will be enum. Ever says it means you can't have a mix of public and private enum variants. Yep. I believe that. I just want to make sure that the same logic applies to functions for enums, and I'm sure it does. Let's find out though. Enum visibility. And we'll vim source main. Basically, we'll do this. And actually, we can do it before this. And then main, we can basically do this. All right, so now we want to create an implementation of appetizer and have a public function called testing, and then we'll just print line and say it works. Okay, and then over here we can say we'll just say back of house, and in fact I'll just do create back of house appetizer testing. Okay, cargo run, it works. And now if we go back in there and we remove that keyword, we immediately get a syntax error, and it says testing is private. If we were to try to run it, we would get an error highlighting that it's aborting due to testing being private. So, yep, that works. I'm gonna have to keep it in my mind that we can do functions on enums, which is kind of cool. And it makes total sense that you couldn't have like soup be private and salad be public. All right, we'll cover use itself first. So bringing paths into scope with the use keyword. Might seem like paths we've written to the call function so far are inconveniently long and repetitive. Yep. I'd agree with that. So we can say use hosting, and then we can just reference the last of the namespace and the function. So that's very straightforward. Creating idiomatic use paths. In 7-Eleven, you might have wondered why the specific use create front of house hosting and then called hosting add to waitlist in eat at restaurant rather than specifying the use path all the way out to the add to waitlist function to achieve the same result. Right. Although both 7-Eleven and 713 accomplish the same task, listing 7-Eleven is the idiomatic way to bring functions into scope with use. And idiomatic just means the Rust way. You know, it's the language's preference and the community preference. Bringing the function's parent into scope with use, so we have to specify the parent module when calling the function, makes it clear that the function isn't locally defined while still minimizing repetition of the full path. Okay. Yep. So you bring in your collection hash map. That way you say hash map new rather than just new. I'm on board. I think that's perfectly fine. As you see, using the parent modules distinguishes the two result types. If instead we specified standard fumped result and standard IO result, we'd have two result types in the same scope, and Rust wouldn't know which one we meant when we used result, and it would definitely throw a compilation error. Providing new names with the as keyword, so it's just aliasing. So we got fumped result and IO result, so we alias using as for IO result. And then function 1 returns result, which refers to this. Function 2 returns IO result, which refers to this. Re-exporting names with pub use. Okay, this I should read. When we bring names into scope with the use keyword, the name available to the new scope is private. Okay. To enable the code that calls our code to refer to the name as if it had been defined in that code scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope, but also making that item available for others to bring into their scope. Okay, so front of house, hosting, add to waitlist, from the crate, front of house, hosting, pub use, hosting, add to waitlist. By using pub use, external code can now call add to waitlist function using hosting add to waitlist. If we hadn't specified pub use, the eat to restaurant function could call hosting add to waitlist in its scope, but external code couldn't take advantage of this new path. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, people running the restaurant think about front of house and back of house, but customers visiting a restaurant probably won't think about the parts of the restaurant in those terms. With pub use, we can write our code with one structure, but expose a different structure. Doing so makes our library well organized and for programmers working on the library and programmers calling the library. I don't feel like they give... Maybe I'm missing something. I would expect to see another implementation that uses front of house. Let's look up an example. Re-exporting example. Yeah. Yeah. Go ahead and do that, EverX. I'm just curious. I mean, I think I get the concept, but I need a little bit more context to be sure. I suppose I could write one too, but then I would have to I suppose I could use two different files and then just use that. So cargo new, and we'll just call this re-exporting. Okay. And we'll just use this example. So we can say these three guys go in here. And actually, I would expect this to go into another .rs, for example. And then if we were to use would it be crate? Let's try it. Well, can I super here? No, don't want to super there. All right, that was quick. Okay, so A, B, C, X prints test. Pub use A, B, C, X. External crates can now call crate X. Okay, so that's the big thing. So if I'm internal, it doesn't matter as much, right? Crate front of house hosting. Let's try it, I suppose. Cargo run. Unexpected token. Yes, only reason is if you're writing a library with the deep structure of modules, but don't want the library consumer to see it or to bother with the depth, right? Yep, makes sense. Let's finish this real quick. Okay, so it doesn't like this import front of house, maybe missing an extern. Is it external? So like, for example, how would I do this? I've got two files and I want to reference between them. Wouldn't be front of house. Is it considered external? Okay. Front of house.rs. W front of house.rs. Okay. Or front of house / lib rs. Still not happy. I don't think I need the extern. I'm gonna get, oh, whoops. Well, that would do it. There we go. Nope. What's the error? So the error is we can't import crate front of house. Says maybe missing. Mod front of house. Front of house. It's the same both places, and then we use crate front of house host as hosting. I don't want to get too caught up in that. I just want to know how to import or use a module from within the same crate. Anyway, yeah, you can specify external dependencies in your cargo toml. It'll go out to crates.io, make rand available to the project. You can then use to bring in rand range, and then you can just call rand thread range. And this is re-exported, it looks like. Members of the Rust community have made packages available to crates.io, and pulling any of them into your package involves the same steps. Listing them in your package's cargo toml, and use the use statement to bring them into scope. Note the standard library is also a crate that's external to our package. Because the standard library is shipped with Rust, we don't need to change cargo.toml to include std, but we need to refer to it with use. Nesting paths to clean up large use lists. Okay, yeah, so you can say standard, and then CMP ordering and IO can both be brought in. We can use nested path at any level in a path, which is useful when combining two use statements. Yep, so instead of doing two, we take itself and right and bring them in. This brings IO and IO right. Alright, so the glob operator, if we want to bring all of the items defined in the path into scope, we can specify the path followed by an asterisk, and that is the glob operator, and it'll bring them all in. Glob operator is often used when testing to bring everything under tests into the tests module. We'll talk about that in how to write tests in chapter 11. Okay, yep, here we go. Thank you. So far, all the examples define multiple modules in one file. When a module gets large, you might want to move the definitions into a separate file to make the code easier to navigate. For example, let's start from the code listing 717 and move front of house module into its own front of house RS. Working on it. So, they say mod front of house, public use front of house hosting, add to waitlist. And that's in librs. In my case, it's going to be main. Yeah, no, I did and I didn't. I did in the sense that I've got mod front of house, but it didn't just define it there. So basically it's like, this is mod front of house. And then create, okay. Use crate, pub, use crate. Unresolved import, no hosting in front of house, right? And then, so we take this, we remove it from that scope, and now we can call eat at restaurant from here, like eat at restaurant. Do we do hosting eat at restaurant? What is it? Crate? Oh, cannot be found. Pub function eat at restaurant. But if we did this move, would we have it? Self? Or can we just say add to waitlist? and delete the eat. I'm going to say hosting, eat a restaurant. Okay. Well, it wouldn't be front of house. It would be hosting because, oh, I see what you're saying. So you're saying if I were to undo that and paste it in here, and then we would say hosting, and this would become front of house. But I thought that would just be crate, but I guess I was wrong. Because crate is no longer, would it be crate front of house? There we go. Got it. Now, let's create something else called other.rs mod other, and then it'll just have a function called testing that thumped. My dog is snoring so loud. Nope, not thumped. Prints other module. Okay, and then we can use create other. Yep. And then say other testing. Why are you angry? No other in the root. Oh, I did it again. Move other to source. Vim source. You know what? I'm just gonna cd into the source directory because I keep doing that. Vim main. Still not happy. Now you can re-export for example. Yeah. Yep, we totally could. So e other mod other. Oh, didn't think so. Wouldn't be pub, and there's no reason for me to re-export. Mod other needs to be at the top of main. Oh. Really? Well, what if I wanted a totally different module inside of my crate? I wouldn't expect to call this other. Well, now I'm confused. What am I not understanding about modules? Well, let's see if this compiles at all. Cargo build. Yeah. Mod other. File not found module other. And other rs. Okay, so vim source other. I will have to reevaluate this soon. We're just going to get rid of others. And in main, we're just going to change it to front of house again. Okay. So, definitions from the body of the front of house module is shown here. Using a semicolon after mod front of house rather than using a block tells Rust to load the contents of the module from another file with the same name as the module. Could I do both? Could I just be like mod crate, and then in other.rs mod other, and then pub function testing print testing. Do not place mod other in other. Okay, so it's just assumed. I think I understand. So there we go. All right. Cargo, not build, but run. Yeah, and there we go. We got testing. Okay, understood. All right, so here's what I wasn't understanding. In my mind, I thought that this was defining what module main was. It is not. What it is doing is it is looking for a module as defined by file name, I think. So it'd be source, other, or we'll, for example, front of house. So front of house is the file name, thus the module, and it has a module in it called hosting. Yes, mod serves two purposes, depending on if you use the block scope or not. And that was the confusing part for me. So, yeah, it's almost like I would expect this to be use front of house, but it's not. And then we just re-export. Okay, understood. Okay. The module tree remains the same. The function calls in eat at restaurant will work without any modification, even though the definitions live in different files. This technique lets you move modules to new files as they grow in size. Note that the pub use create front of house hosting statement in the librs also hasn't changed, nor does use have any impact on what files are compiled as part of the crate. The mod keyword declares the modules, and Rust looks in a file with the same name as a module for the code that goes into that module. Okay. Okay. Got it. Got it. All right, so that wraps up this chapter on packages. Only got you for me was the mod keyword and the semantics of what it's doing, but honestly not that bad. Unfortunately, I think I'm gonna have to call it there for tonight because it's 12:30 here. Is there any lingering concepts? No, I don't think so. Did I see a pub in your mod in main? Probably. So, are you referring to this here? Am I missing something there? Why would you need pub in main? Are you making a crate? Yeah, so this, yeah, so the only reason I did this in main was because I didn't want to use a library, basically. I didn't want to have to bring it into another project, so I just kind of cheated and used main. Oh, okay. Yep, so I just kind of created a non-lib crates, I think is what this would be called. Maybe that's what I can do real quick, is just pat down this terminology here before I go. So, yeah, packages lets you build, test, and share crates. creates a tree of modules that produces a library or executable. So yeah, I created a executable crate rather than a library crate. Modules in use let you control the organization, scope, and privacy of the paths. And paths are a way of naming an item such as a struct, function, or module. Okay, so I'm going to do a quick example. So I'm going to cargo new, and we're going to call this, I don't know, like a car factory. All right. And we'll just have it as an actual executable crate. Got to get this terminology down. So in main, we're like, okay, what would the things we would need in a factory need to be? So what are the modules of a factory? So you've probably got paint. You've probably got like body panel forming. What would you call that? Just fabrication. You've got assembly. You've got wiring, so on and so forth. Struct can be path, OS path. Can be custom data type. Interesting. Yeah. Yeah. Oh, can be OS. Wait. Oh, so path can be custom data types. Yeah. Yeah. it with the so it makes more sense. Struct can be path, so path can be custom data type. Yeah. And we'll demonstrate that, right? So we've got paint, fabrication, assembly, wiring, and then we're just gonna say let's play with this. So cd to source e paint dot rs e assembly dot rs e wiring dot rs and fabrication e fabrication dot rs. Okay, so do we have, I'm getting a little far ahead of myself on some of the architecture here. You can also, for test, create paint librs, mod rs. Is this like specifically for testing? I haven't gotten to testing in Rust yet, unfortunately, so I'm not TDD at all on this stuff. I would think we would fabricate first. Let's not worry about painting. Yeah, it'll be easy. So fabricate first, then assemble, wire. Wiring is probably going to be part of assembly. No, I meant for testing purposes, a module can be a directory with multiple files or a single file. I see. Okay, we may do that. All right, so what would we expect? Let's go out of this and just vim source main cd to source, and then we'll look at fabrication. Did I not do that right? Wonder where those went. Okay, so we'll touch fabrication.rs. Okay, so inside of fabrication, we could have, we could maybe have structures for each of the machines, and those structures could have functions. So I need to go look back on structs, and I don't remember exactly what the struct syntax is. Okay, right. Struct, and then we would just say hydraulic press. And then, so that's going to have like part, and that's going to be a type of part. Struct part, and a part's going to have like a name. Are these capitals? No. That's going to be a string. I think this feels right. And then there's commas there, huh? What else can a part have? Like a number, like a part number, which can be a string for all I care. I don't want to get too carried away here. And then an implementation of the hydraulic press will be activate. And then we'll make that public. And I think that means I have to make this public. But basically, I can pass in. So I'll create a new press. Okay, so let's just have a public function. We'll call it build. And it will have a hydraulic. I'm trying to remember. I think underscores are used in Rust instead of camel case. You probably also want a new method. Yeah, that's a good idea. So pub function new. I think that'll work, and that'll just return a. How do you instantiate a struct? Just that, okay. A new, and I think it would be lower cases here. Right? No, they're doing uppercases. Just kidding. Do they do underscores when they have more than one word? Impossible to know. Oh, just like hash map. There you go. Okay, cool. So for hydraulic press, we'll activate or create a new, return a hydraulic press with, so we would pass in a, was it part string? Okay, and then we'll say part is equal to, no, var or let. It's always name colon type. Okay. Too many languages. Switch those two up. So sometimes you just gotta write stuff like this so you can realize where your brain hasn't quite put it together. So we're gonna say a new part, and I think we can say name is part. Ooh, duplicate name. name, number, and we're just going to say string from temp part number, and then we will, in hydraulic press, part becomes part. Oh, and I do remember that I don't need to do that when I'm naming them, I think. You also don't need the return keyword for returning. You can just in the block without a semicolon. Right you are. Okay. All right, and then activate acts on the hydraulic press itself. Was there a different way to specify static function? Rust static functions. No. And of course, you could just line the part because it's short. Yeah. So you're saying this guy, name, number, and then I could also just inline it to here, maybe, but that gets a little weird. Then I would have to say part like that, I think. Does that work? All functions are static. Specify otherwise with self, reference self, or reference mute as self parameter. They are by default. Yes, that. Okay. All right, so, and then we can just like, I'm going to keep that on separate lines for my own brain's sake. All right, so press is equal to let press be equal to hydraulic press new, and we're going to call it a door panel. Okay, so, and then we say press activate. And we want to return. Okay, so a couple of things missing here. First, new needs to return. Return its self, and activate is going to return part. Install fumpt from Rusty. You can call cargo fumpt, and it'll auto format your call to the standard formatting convention. Okay, yeah, I think I already have it. I just need to have that happen on save. Let's queue out of here. Basically, we want a CD up here to car factory, and then cargo fumpt. Yeah. Let's just do what we have so far. Yeah. And then E. Yeah, and there. You can use self instead of typing the name. So return self. Oh, that's cool. And that'll be the implementation. Self with a capital. Yeah. Okay. So it'll return itself. Yeah. Self will be the type of the implementation. Cool. So then activate, basically we've got the part, and we're just gonna have this. Pressed. And that's gonna be a boolean. Boolean. Bool. Really? Rust. Self will be the, you can even do it on line 14 if you want. It just results in less typing. I'm all about less typing. I'm also about readability. So, Rust, what was the question? Oh, bool type. Would it be... It's so weird. Why is it lowercase? Rust types. What would they be called? Primitives? Scalar, integer, my boolean. Floating, numeric, boolean. Yeah, just lowercase b. Am I losing my mind? Why is string? Because string is not a base type, right? Okay. Anyway, so we've got pressed. When we build it, pressed will be false. And then when we activate it, basically we already have the part, and we just say self dot pressed is true, and self. Can we just return self that way? Line 14, which is different at this point. You're saying this could be self? Okay. Need to add the self arg. Activate. Okay, right. Reference to self. Mutable. Okay. Ownership. So, let's follow the ownership chain. First, we come into build. We create a press, hydraulic press, and we pass in. This should really be string dot from, or colon from door panel. Activate returns part, which is not self. Right. Oh, right. What? Okay, hang on. Hydraulic press dot part dot pressed return self dot part. Okay. What does hydraulic press activate conceptually do? What is it returning? Basically, I'm like, here's an implementation of hydraulic press. Pass it a part. It's going to press that part and return the part out of the assembly line to the next part, or to the next module in the assembly line. So we go to the self part pressed becomes true because self is mutable. I'm not. We'll see. I'm confident stuff will break here. Then we press activated. We get self back. So the ownership chain. New. We return self, which I imagine. Do we need to make it mutable? This will get tricky. Yes, that's why I'm doing it. I needed to be able to understand all of this ownership. You'd not use a struct for this. Okay, what would you use? Would be a function instead. Okay. Well, let's do that. Just one function? Even though it's like a thing conceptually? And it would just take it apart? And then, okay, that simplifies it. So we have pub function, fabrication, hydraulic press, takes in part as part, and returns the part. We just press it. And then we don't have to new here. Instead, we new like here. Let part equal part. I see what you're trying to do, but in a real code base, you never write anything this way. I'm just worried you might get bad habits. This looks like a Java factor type of sorts. Yeah, I'm just kind of playing with the idea right now. I'm not basing it on much. But I am all for taking encouragement to do things a different way. So, new goes away, and then basically we do something like this. And really at that point, it's just this. And then fabrication, let's be specific. Yeah, so really it's just this. Okay, this is starting to look better. I'd say write your own vector if you want to give ownership a try. Your own vector. To what end? Vector, I'm trying to remember vectors. Would it be a vector of parts? What chapter is this? I have not gotten to vectors yet. That is next chapter. So or is it? Is this an old book? Yeah, vectors is the next chapter. So I'm not going to touch those yet because I haven't properly learned about them. They're lists, I guess, depending on where you come from, or sets. Yeah, okay. So we're not going to do that yet. So what we're going to do is we're going to use what we know. Okay, so this goes away. We have a part. We press. We take in. We're going to say actually just a name. as a string. Put the name in the part, give it a number, pressed is false, which is useless at that point. I want to see state change. So I am going to pass in a part. And then I'll handle this stuff out in main, I guess. Which means I need part to be a public structure from fabrication. So we have a part, we take it in, and then we just set it to true. Yeah, I know. I'm only doing state change like this for educational purposes. I'm really not. I just am trying to get the semantics down here a little bit. Okay, so we have a part, and then from fabrication, we just call hydraulic press, pass in our part, and here, this is exactly why I'm doing it like this. I just want to modify this, right? Because if I'm reminding myself of ownership, I know that I have to pass this in as a mutable reference, and then I can print part.pressed. And then so part comes in, part gets pressed, we return part. Let's fump that again. Okay, so it's unhappy. Expected dot on line 9 of main. Oh, I did it again. So it's not self, it's just part. And then on line 9, it's complaining about what? What did I do wrong? Got it. Okay. Line 8 needs a semicolon. Yep, that it does. Sorry, too much go. Too much go. I almost wish... I'm not sure I'm a fan of this whole optional semicolon for return thing here, because it gets my mind all confused. At times I think they're not necessary. Also, I'm used to like struct not requiring them, right? So it's done for closures. Yeah, understood. I mean, I get it. It's just not the most intuitive syntax. Simple closures that return anything comes in. Exactly. Yeah, and I'm sure it's done for the compiler at compiler time, just to make things super verbose. All right. Well, let's do something with this. Cargo run. All right. Boom. Explicit struct part found reference. Oh. We want a reference of part. Name not found in scope. On line 5 of main. Name equal to string from door panel. unpressed obstruct part is private. Can I do that? Nice. It makes the code look a bit prettier. Yeah, just more work. Yeah, I agree. I'm all about the, but that's like arrow functions in JavaScript. The syntax of which you describe the function dictates it not needing a return or a semicolon, whereas in Rust it's part of all functions. Anyway, so return part, expected, found reference. Reference, part goes back. Part pressed, which is cannot assign part pressed. Is that right? Public mutable struct? No. Do I need to bring in mute? Here we go. Okay. I just need to keep writing this stuff. So, and then I pass in a mutable part. Ooh. Okay. Octopus, how bad am I writing code right now? It's beautiful. Okay, so you're saying because... Wait, hang on. There's no use for the ampersand part return. Here? Oh, you know what? You're right. Yeah. Because that would just be me returning a reference, which would be completely useless unless I wanted that memory address. The rest way would be to have an unpressed... Yeah, why am I not using generics? Anyway, to have an unpressed type and a pressed type and have the function convert the unpressed into a pressed, I guess. Okay. Yeah, that makes sense. And then just return... And then we would have a new part rather than changing state over time. Then you'd have no bool. Right. And you would avoid state change. Let's do that. Unpressed part. A pressed part. The functional way, the functional way you'd need to know traits though. I don't think I've touched traits yet, unfortunately. I get the concept, but I don't want to be using things I don't know about yet. I know if he's done traits. No, I have not. Generics don't work the same way as they do in most others. Well, good. Then I'll learn something. Have I touched generics? Yeah, so basically, I'm not allowed to write code until chapter 10. Got it. Okay, then I'm not going to do that. And I'm just going to be using state change like a scrub instead of using immutability. And I'm going to pass mutable references of parts, and it works. We'll press in those panels. Okay, I think I get the gist of this. I can write code. It's just not pretty yet. Okay, so generics don't work the same way, but you, of course, could fake it. I love faking things. You can always do it the non-generic way, unpressed part and pressed part. Yeah, I'd rather not. I'd rather take in the generics. And consume an unpressed part, and it creates a pressed part. Yeah. Yeah, you guys definitely did type the same. Okay, so let's go ahead and end it there. I call this a successful learning experience. It's actually very, very helpful to have people who write Rust in the chat to sort of put you back up on the right track. Also what? You can make hydraulic press be an implementation of the part. Yeah, true. Yeah, but I don't want to do that, because when it comes to generics, it'll make more sense for it to be not part of the part. So part press, yeah. But you don't, like, the part itself isn't in charge of pressing, you know? So if anything else, it would be like the struct would be like a part of the function. I'm not going to do it. I don't even know if you can do that. Well, and Rust says, yes. Yes, you can. That gets weird. Anyway. Pressed from unpressed new part. Yeah. Top tier programming. Agreed. 100%. 100%. All right. Well, thanks for the input. I'm probably going to be streaming maybe tomorrow, unlikely, but possible, and then definitely Thursday around the same time, and then we'll see about the rest of the week. So thanks for tuning in, and as always, I'll see you next time.